enterprise or public cloud data center is a critical component of any vision of a pervasive, data-driven experience story. Many interactions in the physical world and the virtual worlds will require a data center backend. Data centers house roughly a third of all data on Earth today, roughly 20 zettabytes in 2020, and are projected to grow between 15 and 20% annually through 2025. The challenge is not only the sheer volume of data and users that must be supported, but also the need for time-sensitive processing and responsiveness. The evolving nature of workloads and services that they provide also poses new considerations for data center managers and architects. How can data centers deal with this volume and growth and changing workloads efficiently? Well, general purpose computing and open platforms are a prime source of efficiency for dealing with data and services at scale. And this is largely due to two factors. Firstly, large-scale operators evolve models for building and operating data centers at unprecedented scale-out architectures. The second factor is enabling scale-up, optimization via the addition of heterogeneous compute elements. As cloud, virtualization, and hyperscale approaches have matured, workloads and services also have evolved, becoming more microservice-oriented and more composable. These include voice processing, video analytics, data mining, intensive simulations, and realistic visualizations, to name just a few. This means that a growing number of services will likely require far more than your run-of-the-mill general-purpose server to operate effectively and efficiently. Fortunately, general-purpose platforms have the flexibility to adapt to needs. Consider our examples here. The system on the left is configured to provide the resources that roughly match a general-purpose server instance at a cloud provider to meet more traditional workload requirements. The system on the right represents a resource configuration for an instance intended to process an AI-centric workload. This configuration has many times the compute, memory, and storage capabilities, 8 GPUs, each with gigabytes of dedicated high-bandwidth memory, multiple CPUs, much more storage and memory relative to a general-purpose system. Clearly, one size does not fit all. Automation of provisioning and workload placement can help, but only if the required resources are available to be used. So the ability to transform the general-purpose server into a composable platform, providing the acceleration and storage and memory necessary to meet workload requirements, is critically important. Being able to utilize open platforms works, as long as all of the ingredients can keep up with the requirements. If not, the system can become unbalanced. We may see bottlenecks between the CPU, memory, accelerators, storage, or I/O. The result of that is often bad response times, maybe dropped packets, pixelated videos, leading to bad user experiences and the potential for lost business. A primary focus for Micron is to stay ahead of that curve and to work with our key ecosystem partners and standards groups, such as OCP, to advance memory and storage technologies as part of scalable platforms. This includes innovations in DRAM and NAND architectures to meet emerging needs and to combine with new CPU, graphics, and I/O devices and enable breakthrough performance and efficiency. We are the industry leader across DRAM and NAND, thanks to our 1-alpha and 176-layer NAND technology processes. Process advancements are always exciting and promise major leaps in performance, density, and capacity. But we also continue to deliver advancements within our current process generations too. For example, earlier this year, we announced our new addition to our data center SSD portfolio. This new drive, the 7450, is based on our proven leadership of 176-layer NAND. And through the use of Micron DRAM, a Micron-built controller, and our unique secure execution environment, we are able to create an enhanced solution that delivers 2 milliseconds of latency at 6 nines quality of service, and with more robust security. Our collaboration and innovation does not stop with Micron or our partners. We contribute significant quantity and quality of experts to the key standards that have been making open systems innovation so successful for so long. Bodies such as JEDEC, NVM Express and SNIA communities benefit from Micron's contributions and leadership in key technical committees. With that in mind, I'd like to highlight some major standards-based technologies that promise to make a major impact in data center environments. These are Compute Express Link, or CXL, and DDR5, which I touched on earlier in our client discussion, but would like to revisit in the context of data centers. So CXL is a new server interface that enables unprecedented levels of system composability and efficiency. This is a real breakthrough and allows completely new ways to implement additional capabilities onto a general purpose platform. CXL builds off the base of PCI Express and resolves many of the issues and limitations with previous bus expansion architectures, and it allows for incredible flexibility. With CXL architectures, capabilities such as memory, accelerators, I/O devices, and storage can be easily plugged into the system, accessible via high-speed connections to all CPUs. This is particularly promising for acceleration and memory expansion, which can struggle to scale effectively given traditional limitations on available DIMM and PCI slot resources. For example, CXL 2.0 promises a 32 gigatransfer per second full duplex infrastructure to accommodate additional low-latency resources. If a system needs many workload accelerators, such as our AI workload configuration example that we showed earlier, that's easily added. If more memory than the available DIMM slots allow is required, additional memory can also be attached via CXL. This allows the creation of enormous pools of memory to be shared by any of the high-performance processor cores and accelerators, and enables breakthrough levels of flexibility and scalability. The imminent impact of DDR5 in the data center will be even more profound. DDR5 was designed for the demands of the data center. In terms of memory innovations for the data center, it is a game changer. Data centers transitioning to next-generation server platforms starting later this year will be challenged by platforms with hundreds or more processor cores each, and incredible low-latency I/O needs. Memory is a crucial part of allowing these high-performance compute elements to be able to handle data efficiently, and DDR5 will deliver the goods. Micron DDR5 delivers more than double the bandwidth, offering the next generation of performance, reliability, and scalability with lower total cost of ownership advantages over DDR4. We've been working with partners across the ecosystem over the last 2 years to be ready for DDR5 through our Technology Enabling Program, or TEP, which has provided early access to documentation and design tools needed to build DDR5-based systems. More than 450 systems designers have used TEP as the pipeline for new capacity points and speed bins get defined. This collective work has readied the industry for DDR5 adoption.